Okay, I wanted to make a video for everybody out there that's trying to run CNC router, high RPM, 15, 20,000 RPMs, cutting aluminum. There's a lot of information online, a lot of people's suggestions, a lot of opinions, and a lot of it's wrong. We've been cutting aluminum for about 15 years, and just recently we've decided to deviate from what everyone's been telling us. A lot of the feed rates, the RPMs, the bits that you use, most people say use single spirals, which do work pretty well, but they're very expensive because it's more of a specialty bit versus a regular milling bit. You'll pay almost twice as much for the bit as you would a standard, inexpensive carbide double spiral. One of the things people tell everybody is you're going too fast or you're not going fast enough. We've come to learn that you're just not going fast enough. The high RPM is the downfall to these machines. You've got high RPM, low torque usually. We've been cutting 3/4 inch 6061 aluminum all day long with 1/2 inch double spiral and 1/4 inch double spiral, and haven't broken one yet. We do have a oil mister that we use, a really lightweight cutting oil specifically for aluminum. I'll post what brand and grade of oil it is in the comments. But let me show you guys what feed rates we're using, and I've checked like 3 different online chip load calculators to verify that what I'm doing is what I really think I'm doing, and it seems crazy fast. Most people that have a CNC router are going to be like, there's no way in hell my machine's going to do this without breaking. And it will. We didn't think so either. Right now with our 1/2 inch and 1/4 inch end mills cutting 3/4 inch thick aluminum plate, we've got a 6 foot by 12 foot sheet on the table right now that we're cutting. And we've been cutting for about 10 hours today, haven't broken a single bit. The feed rate, well, first of all, our machine is an old Vytek CNC router, 6 foot by 12 foot. It's got a 10 horse, I forgot what the model of the spindle is, HDI or HDU, something like that. Anyway, big European 10 horse spindle, air release collets, and it's standard 20,000 RPM. So we try to keep it spinning as fast as we can so we can cut as fast as we can. And we've come to find that feed rate wise, the faster you go, the better of a finish you get. The downfall to that is the faster you go, the closer you're getting to the point to where the bit could break. So you have to try to find that sweet spot where you don't quite go crazy with it, but you do want to cut faster than you probably are cutting. Trust me, you'll see in a few minutes. We've got a couple of tool paths set up where the machine's going to hog out some bigger chunks of aluminum using the 1/2 inch end mill, and then it's going to switch over to the 1/4 inch end mill, and it's also going to hog all the way through. And we're doing multiple passes. I'm taking it kind of easy on the depth of cut because I don't want to break them. We're kind of on a deadline that we have to hurry up and get this job done in the next couple of days. So I really don't want to start breaking bits, so I'm definitely taking it a little bit easier than I probably could on the depth of cut. I think right now we're running roughly about 1/8 of an inch with the 1/2 inch end mill and about a 16th or 0.80, something like that. I think it's like 0.80 with the 1/4 inch end mill. We could probably double both of those, but you know, that's going to double our chance of breaking bits, which I'm trying not to do at the moment because, you know, they're not cheap. But right now, our feed rate, most people are going to, machinists, go by inches per minute. We go inches per second just because that's the way our software calculates everything easily for us. But inches per minute, right now we're cutting about 100 inches per minute, which breaks down to 1.66 inches per second. Yeah, that's right, almost 2 inches per second with a 1/4 inch and 1/2 inch end mill. So if you've got a foot long part you want to cut, shouldn't take any more than 10 seconds. 5-10 seconds, it's done. It sounds really fast, and trust me, it's a little scary at first, but until you get used to it. When we're cutting with the double spiral 1/2-inch end mill, it will literally throw chips that are probably about 400 degrees 15 feet away from the machine. But that's what it has to do to get the heat away from the carbide bits. Heat is the one thing that will break your bits every time. If you think you're cutting fast, but these things want to really cut fast. So you have to up your feed rate or drop your RPM. If you drop your RPM with a router, everybody knows you start losing torque. So we've opted to just go as fast as we can and not have the machine jerk around too much, because it's a big, heavy steel industrial router table. It's not one of those Tinker Toy lightweight aluminum jobbies. So that's the one downfall, is that, you know, if we try moving too fast in any direction, the machine will start to jerk around a little bit, and that'll cause some extra ripples and divots and stuff in our finish. So we try to keep the feed rate roughly 1.5 inches per second. We've cut up to 2.5 inches per second and haven't had any problem. The faster we go, the smoother the cut is. If we were just cutting straight lines, I'd have no problem running at 2.5 inches per second and get almost like a mirror edge on it. So like I said, right now we're going to be running the machine at about 100 inches per second with a 1/4 inch and a 1/2-inch end mill, double spirals. We bought all of these bits from toolinghouse.com, which is luckily local to us. They're a special online mail order company for machine bits, and the guys got ridiculously cheap prices versus going to McMaster or MSC or Onsrod or any of these companies. Rob Jack, they're all expensive as hell. This guy he has somebody custom make his bits for him in the US, all carbide, and unless you do something really stupid, they hold up incredibly well. And we can't believe how much faster we can cut with the double spirals versus the single spirals we've been using for 15 years. I was told the same thing in the beginning: stick with the single spirals, the machine's too fast, you can't cut with a double spiral. You know, it is more difficult and much more finicky when you go to a double spiral, but once you get the numbers dialed in, it's scary, but it's awesome to watch this thing run. So we're going to go ahead and run out there in a few minutes and send the tool pass that we've already sent out there, cut a few pieces, and we'll probably stop the camera after that. But I want you guys to take a look at a couple different websites. Actually, I put together a spreadsheet for myself just so I could keep track of my feed rates and RPMs and everything. And this is what we're running right now. We've transferred this over to the software, and you can see right here that these are the feed rates that I'm using for the 1/4 inch double spiral end mill. And this is kind of sketchy, but you can see the bottom left, you've got 1.66 inches per second. RPM is 20,000. The inches per tooth, which is what we're taking off per tooth on the double spiral end mill, is 0.0025, so 2.5 thousandths per tooth. So every time the machine does a full revolution, we're taking off 5 thousandths. Okay, and that number I'm going to play with a little bit once we've got this job done, because I really think we can go a little bit heavier. I think we can get up to 2 inches per second, which is going to give us 3 thousandths per tooth, and even better finish, because we just recently jacked it up to 2.5 thousandths. We were running 2 thousandths, and the edge is coming out even better. So I'm gonna head outside and show you guys what we've been cutting all day, and you'll see this is massive. I mean, it's 3/4 inch thick plate, and the machine couldn't care less. So let's go check out what we've got outside. And okay, this is one of the pieces that we worked on today. It's a big art sculpture for one of our customers. But you can see right here, 3/4 inch thick plate, and I mean that is close to, I mean you see little tiny fine ripples, but you kind of have to expect that from a router versus a mill. That's the downfall to it. But I mean the finish is like a mirror. Crazy smooth, just little tiny ripply waves which you could sand out with 80 grit sandpaper and they disappear. And I mean it cut this whole piece out in about, I think it was about 3 hours, 4 hours maybe. And this thing is huge. It's 6 foot diameter circle, and it's probably about I don't know, 7-8 feet long the other direction. It's huge. Okay, so we're gonna head over to the machine and here's the sheet. Like I said, 6 foot by 12 foot. It's huge. That's the part that came out already. This is another piece that we're working on right now. It's coming out of the same sheet. It's got tons of cuts on it. So, forgive all the noise, but our shop is very noisy and you just gotta deal with it. We've got air compressors, air lines. The motor itself is gonna be loud, but here we go. And yes, it has an oil mister on it.